Welcome to my new calculus channel. My name is John Gabriel. Today I'd like to discuss some more topics that really rile me with respect to the hypocrisy of mainstream academia. And in this series, which is called Academic Ignorance and Stupidity, Academic Ignorance and Stupidity, which is part 32, I'll be looking at a concept that I've looked at in one or two previous videos, namely the concept of non-terminating decimals, or non-terminating, non-repeating decimals. So now it is a fact that 1/3 cannot be expressed in base 10. There is a theorem which states very clearly that if you're given any proper fraction, p over q, it doesn't have to be proper, but let's say it's a proper fraction in this case, you're given any fraction, p over q, where the prime factors of q are not 2 and or 5, then it cannot be expressed in base 10. Okay, so for example, if we have a quarter, the prime factors of 4 are 2. Well, 2 times 2 gives us 4. So it's very easy to see that a quarter is expressible as 0.25 in base 10. Yes? Okay. And what we really are doing when we express a quarter in base 10 is we're finding an equivalent fraction in base 10 that can be expressed as a sum of the integral powers of base 10. Okay? This is what we're doing. So we're saying, how many of these do we need? 2 of these and 5 of these. And when we add them together, we'll get 0.25, right? Because this is the same as 20 over 100 plus 5 over 100, which is 25 over 100, which is 0.25. Okay. So in this case here, the limit is equal to the sum, right? So the limit of this sequence is equal to the sum. No problem. Okay, now let's take a look at 1/3. Now, with 1/3, it's impossible to find an equivalent fraction. Okay, it's impossible to find an equivalent fraction so that we can have 1/3 expressible in base 10. There is no such equivalent fraction. Why? Because 3 is not a prime factor of 10. Okay, the prime factors of 10 are 2 and 5, and 3 is not 2 and 5. So it's not possible to express 1/3 in base 10. Now you may say, okay, well, we can take the limit of this, which is 1/3. Oh, alright, so let's do that. So we'll say that 1/3 is equal to 0.333 ... But that's a contradiction. It's hypocrisy, because we know that even if we could have completed infinity, which is absolute nonsense, okay, completed infinity? What rubbish. In fact, infinity is a junk concept. But here the mainstream morons are going one step further and imagining completed infinity. Okay? There is no such thing as infinity, and completed infinity is junk. So in this case here, the number here is equal to the limit of the sequence. In this case here, it's equal to the sum as well as the limit. And now for the final stage, we look at the value of pi. Well, what on earth is pi? So mainstream morons will write pi is equal to 3.14159 ... but nobody even knows what the limit is here. So in this case here, it's not a limit, it's not a sum. What the bloody hell is it? Okay, so idiot mainstream academics have 3 rules for defining a number. Okay, in this case here, the sum is the number. In this case here, the limit is the number. In this case here, nobody knows what on earth pi is. Okay, so the mainstream definition of number is complete junk. It was developed from the idiotic theories of Cauchy and Dedekind. So Cauchy stated that a real number is an equivalence class of convergent sequences, okay, an equivalence class. So, well, you can write down the number 1 according to Cauchy in many ways. You can write it down, for example, as 1 minus p to the minus n, where p is some integer, right, greater than or equal to 2. So you can write down 1 as 1 minus 2 to the minus n, or 1 minus 3 to the minus n, or 1 minus 10 to the minus n. And this one here is the one that you normally see as 0.999. All these here are limits. Okay, and so these are equivalent classes, right, or sequences which are part of an equivalent class. So these here are all sequences which are part of an equivalent class, which is 1, right? So this here is absolute rubbish, which you'll learn in a course on real analysis, right? There is no such thing as infinity. There is no such thing as a non-terminating decimal, or a non-terminating, non-repeating decimal. All those concepts are absolute nonsense. To find out more and to learn exactly why these concepts are nonsense, I encourage you to go to my New Calculus YouTube channel, which is this channel over here. And what you can do is you can watch my videos, especially my much acclaimed series on academic ignorance and stupidity. Here you'll see how I refute well-known academics such as Gilbert Strang and Jack Hazinger. Gilbert Strang here and Jack Hazinger here. Okay, and both these academics are idiots. One of them is from MIT and the other from Harvard. I've produced another special episode here on the new calculus derivative for these morons, because these particular individuals have tried to refute my new calculus, which, as you can see in this applet here, can be learned in less than 20 minutes just with a high school education. I encourage you to visit my new calculus site, and also my YouTube channel, and also my new calculus site. Okay, so my new calculus site is basically the new calculus, calculus.weebly.com. And over here you will learn real mathematics, and you will see the 13 fallacies being exposed. Right? You will see the ideas that brought nothing but confusion and chaos to mathematics. So what is pseudo-mathematics? Well, a false concept is that infinity is well-formed. Infinity is not a well-formed concept. There is no such thing as an infinite set. Non-terminating radix representation cannot represent any real number, because real numbers do not exist. There are no irrational numbers. That's a fallacy. No infinite sum is possible. This here is not true. Okay, it's nonsense. Newton never used infinite series. he used partial sums. There are 13 fallacies in total here, and you can read them and you can watch the videos on those and learn a lot more than you've learned in all your school or university years. Well, I hope you've enjoyed this YouTube video and that you'll join me again next time for another interesting topic here on the New Calculus channel. I'm John Gabriel. Till next time.